Alright, so we're in the Helicopter Flying Handbook. This will be Chapter 11, page 5 of 24. This is auto rotation with turns, page 5 of 24. A turn or a series of turns can be made during an auto rotation in order to land into the wind or avoid obstacles. The turn is usually made early so that the remainder of the auto rotation is the same as a straight-in auto rotation. Making turns during an auto rotation generally uses cyclic control only. Use of anti-torque pedals to assist or increase the speed of the turn causes loss of airspeed and downward pitching of the nose. When an auto rotation is initiated, sufficient anti-torque pedal pressure should be used to maintain the helicopter in trim and prevent yawing. The pressure should not be changed to assist the turn. If the helicopter is flown out of trim in forward flight, the helicopter will be either a slip or a skid, and airframe drag will be greatly increased, with which in turn increases the rate of descent. Therefore, for the minimum descent vertical speed, the trim ball should remain centered. Use collective pitch control to manage rotor RPM. If rotor RPM builds too high during an auto rotation, raise the collective sufficiently to decrease rotor RPM back to normal operating range. Then reduce the collective to maintain proper rotor RPM. If the collective increase is held too long, the rotor RPM may decay rapidly. The pilot must then lower the collective and begin chasing the rotor RPM. The RPM begins decreasing, the pilot must again lower the collective. Always keep the rotor RPM within the established range for the helicopter being flown. During a turn, rotor RPM increases due to the increased G loading, which induces a greater airflow through the rotor system. The RPM builds rapidly and can easily exceed the maximum limit if not controlled by use of collective. The tighter the turn is and the heavier the gross weight is, the higher the RPM is. Cyclic input has a great effect on the rotor RPM, as aft cyclic input loads the rotor, resulting in coning and an increase in rotor RPM. A forward cyclic input unloads the rotor, resulting in a decrease of RPM. Therefore, it is prudent to attain the proper pitch attitude needle to ensure that the desired landing area can be reached as soon as possible, and to make minor adjustments from there. To initiate an auto rotation other than in a low hover, lower the collective pitch control. This holds true whether performing a practice auto rotation or in the event of an in-flight engine failure. This reduces the pitch of the main rotor blades and allows them to continue turning at normal RPM. During practice auto rotations, maintain the RPM in the green arc with the throttle while lowering collective. Once the collective is fully lowered, reduce engine RPM by decreasing the throttle. This causes a split in the engine and rotor RPM needles. The technique for an auto rotation with turns. The most common types of auto rotations are 90 degree and 180 degree auto rotations. For 180 degree auto rotations, establish the aircraft on the downwind at recommended airspeeds and 500-700 feet AGL, parallel to the touchdown area. In a no wind or headwind situation, establish the ground track approximately 200 feet away from the touchdown point. If a strong crosswind exists, it is necessary to move the downwind leg closer or farther out. When abeam the attended touchdown point, smoothly but firmly lower the collective pitch control to the full down position, maintaining rotor RPM in the green arc with collective. Coordinate the collective movement with proper anti-torque pedal for trim, and apply cyclic control to maintain proper attitude. Once the collective is fully lowered, decrease throttle to ensure a clean split separation of the needles. After splitting the needles, readjust the throttle to keep the engine RPM above normal idling speed, but not high enough to cause rejoining of the needles. The manufacturer often recommends the proper RPM for that particular helicopter. Cross-check attitude, trim, rotor RPM, and airspeed. After the descent and airspeed are established, roll into the turn. The turn should be approximately 180 degrees. Winds may cause the actual turn to be more or less than 180 degrees. For training purposes, initially roll into a bank of at least 30 degrees, but no more than 50 to 60 degrees. Continuously check airspeed, rotor RPM, the trim throughout the turn. It is important to maintain the proper airspeed and to keep the aircraft in trim. Changes in the aircraft's attitude and the angle of bank cause a corresponding change in rotor RPM. Adjust the collective as necessary in the turn to maintain rotor RPM in the green arc. At the 90-degree point, check the progress of the turn by glancing toward the landing area. Plan the second 90-degree of turn to roll out on the center line. If the helicopter is too close, decrease the bank angle. If too far out, increase the bank angle. Adjusting the bank angle will change the G loading, which in turn alters the airflow and results in rotor RPM changes. Keep the helicopter in trim with anti-torque pedals. The turn should be completed in the helicopter aligned with the intended touchdown area prior to passing the 100 feet AGL. If the collective pitch was temporarily increased to control the RPM, it may need to be lowered on rollout to prevent decay in RPM. Make an immediate power recovery if the aircraft is not aligned with the touchdown point and if the rotor RPM or airspeed are not within proper limits. Otherwise, complete the procedure as if it were straight in auto rotation. Common errors: failure to maintain trim during the turn, increases rate of descent, failure to maintain auto rotation speed, failure to hold proper pitch attitude for type of helicopter too high or too low, failure to have proper alignment with the touchdown zone by 100 feet AGL, failure to maintain rotor RPM within limits during the maneuver, failure to go around if not within limits and specified criteria for safe auto rotation. All right, so we'll hold off there. That is page 6 of 24. That is auto rotation with turns, chapter 11. See ya.